Excuse me. Good afternoon, consortium members. I'm Alan Johnson. I'm representing General Atomics Commonwealth Computer Research, and I'd like to give you a background as far as our corporate capabilities are concerned. General Atomics Commonwealth Computer Research is a large defense contractor founded in 1989. We are a spinoff of University of Virginia Systems Engineering Department. We have locations in Charlottesville, Virginia, Herndon, Virginia, and offsite staff in both ADFC and Air Force TMCAP. We were acquired by General Atomic Technical Corporation in March 2021, are now an affiliate of that organization. Our focus and vision of General Atomics CCRI is to provide global situational awareness capability to the U.S. government and commercial organizations in a variety of different ways, which you'll see in the slides that follow. And our mission is to empower decision makers by applying three key elements: innovative data science, scalable software engineering, and advanced visualization to help them in their requirements, solving those challenges. What do? We process multi-source, multi-int data at scale. On the left-hand side, you can see some of those data types. Just to the right of that, you can see some of those volumes and velocities of data that we handle on a regular basis. We apply those three disciplines of data science, software engineering, and visualization against these data sets to produce mission-relevant outcomes, both in the context of tracking and target recognition, space-time predictive analysis, and multi-domain command and control. We have a fairly substantial footprint in the IC and DoD. We experience over 3,000 daily users on our main systems and are present on 12 watch floors 24/7 around the world. Our expertise falls primarily in the maritime and airspace. Air has been a capability of ours for a number of years. Maritime is a more recent addition as far as our main system is concerned. We're increasingly focusing our energies on the ground domain, a variety of sources and a variety of sensing modalities. We also have presence and experience both internally as well as with our affiliates in both space and cyber realms. We are divided into 5 functional centers that represent our data science focus, DevOps, to include information assurance, user experience in the form of user interfaces, software engineering, primarily focused on cloud computing, and finally management and support for budgetary management, customer relationship management, and schedule management. We serve customers across the IC and Defense Department. Our primary customer is a member of the IC. We also work with research centers within all of the services, as you can see here: Office of Naval Research, AFRL, ARL, and others. We have a strong history of working with partners across the defense space as well as commercial space, some of which are represented here. And finally, in our commercial platform offering, which we'll be discussing later, we have a number of customers that we're providing data management support to. We're a highly trained team of researchers, problem solvers, and developers, the majority of having an advanced education, majority of us having SCI clearance, and the majority of us focused on engineering, science, and math. Our overall expertise, as I mentioned earlier, is focused on multi-domain global situational awareness. Aspects of that include real-time information, object-based production to generate a 360-degree view of information, and increasingly application of novel computer vision approaches to augment that information typically obtained through metadata. The key focus areas that we have, as I mentioned earlier: tracking and data fusion. That by necessity means we are processing geospatial big data. Computer vision and deep learning go hand in hand. Cloud computing and scalable computing also go hand in hand, and without a compelling and performant visualization capability, it really doesn't make a difference. So now I'll focus a bit on our relevant technical capabilities, some of which you see here. Our most significant system is known as Thresher. It's a program of record with our primary customer. It is a multi-domain global situational awareness tool. It brings multiple sources of information from across security realms together in near real time. It has a very compelling user experience that supports a variety of analytics. It has a number of feeds, not only to the user interface, but also to downstream systems, increasingly feeding tactical environments. It has a very sophisticated suite of collaboration tools to enable information sharing and common operational pictures and variety of perspectives for a variety of end users. A sister capability to Thresher is the DragonSpell ATR platform for that same customer. On this effort, we perform research and development in the field of automated target recognition, typically in the development of deep learning models. We have developed a processing pipeline that supports very rapid scaling of computing resources in the cloud, up as imagery demands and down as imagery is processed. This program also has a novel aspect to it known as the Mission and Partners Outreach. This is a case in which we can work together with end users, identifying use cases in which ATR may be relevant, identify data sets that our customer is collecting or acquiring that could be leveraged, and developing models and deploying models and working with that user community, all at no cost to the end user. And finally, we maintain and support this system on a 24/7 basis in the same way as we do for the Thresher environment. Also in the deep learning space, we've done quite a bit of work in video processing, full motion video, both in the form of EO and IR, as well as in areas such as WAMI, wide area motion imagery. We've developed analytics that allow us to process full motion video from a variety of sources, both noisy as well as otherwise compromised imagery, to generate meaningful captions that describe the video in a manner that's useful from an indexing, search, and retrieval perspective, such as that shown at the image at the bottom of the image here. This work was transferred from AFRL into the NGA under the Trevor program. We've integrated these video processing techniques with the Terralogix Unified Video Management System, which you may know better as UVDS, UVids, and/or MI Online on SIPRNet and JWIX respectively. Trevor consumes multiple video feeds, applies multiple analytics and models, and generates streams of time-synchronized detections in MISB 0903 format, both for visualization on the Unified Video interface, as well as for downstream consumption as KLV metadata streams. Work we've done for the Department of Navy under the Office of Naval Research. Argo is a course of recommendation engine. It is designed to use a novel approach of application of computer vision to generate a large number of enemy course of action potentials, as well as corresponding optimized responsive course of actions, and then use computer vision to represent these in such a way that emergent phenomena can be determined in near real time, and recommended responses to that phenomena could be generated. Also, for the Office of Naval Research, and in conjunction with the Thresher Program Office, we've developed some advanced analytics that are designed to predict vessel locations based on a variety of sources and a variety of means, some of which are shown here. For the Army's I2WD, we have developed a capability known as GeoSpy, which is a jammer and emitter location prediction engine. It uses novel analytics that segment a space in a geospatial space and identify distributions of sources within that space to nominate locations of the likely emitter of interest. Also for the Army, we have developed a capability known as KETOS. This is a natural language processing engine as well as a document recommendation system. So in the same way as you purchase items on Amazon and are recommended other items of similar natures with a variety of aspects of similarity used, KETOS applies that approach to the process of generating finished intelligence. If you're reading this, then you may want to read that. If you're reviewing this, then you may want to talk with this other reviewer to help construct and enrich intelligence in a manner such that it is most consumable and most useful for downstream use. And finally, as I mentioned earlier, we have a number of commercial customers that we're supporting with some of the technical underpinnings that are described here. That's known as Optics. Optics is a data fusion framework based upon open source technologies as well as those we have developed ourselves, specifically GeoMesa, Stealth, and Orion. Optics is a platform as a service. We can help you ingest your big geospatial data, manage that data for you, and then support you in the development of analytics and/or visualizations and other downstream use cases that may be beneficial to you as an organization. This is based upon the technology that powers Thresher, so it has the same security attributes as well as performance attributes as does that system. And it is highly complementary to a number of other tools that we can bring to bear, some of which I've discussed here today. Optics is comprised of a number of components. Optics Geo is based upon the GeoMesa toolkit, which is an open source product. If you go to geomesa.org on the open internet, you can download this freely, stand up your own environment if you so desire. It is a standards-based open geospatial consortium, specifically GIS data provider. It works in conjunction with the open source product known as GeoServer to provide a means by which data indexed and stored within GeoMesa can be retrieved into a variety of visualization and other analytic environments. Why would you use Optics? For any case in which you've got large spatiotemporal data sets, such as corpus of AIS, ADS-B, personal mobility data, other types of location telemetry data, Optics Geo and/or GeoMesa are fine technologies to use to manage that information. Its counterpart is known as Optics Viz. It's based on CCRI's Stealth UI/UX framework, which is the user experience that powers Thresher. It too is based upon OGC standards, so it can talk to Optics Geo as well as any other OGC compliant backend, such as Esri or Oracle Spatial or others. So in the same sense, if you're using Optics Geo to manage big spatiotemporal data sets, you can use Optics Viz to visualize and analyze large spatiotemporal data sets. And finally, the primary third component of Optics is its Optics Analyze. It is based upon Spark and open source notebook environment, some of those technologies which are shown here below. We use this to generate analytics both in real time and in batch, both as far as end users are concerned, as well as to provide a compelling interface to the data scientist. So if any of this is appealing to you, you desire to discuss further, both in terms of unclassified or classified fashion, please don't hesitate to reach out to me at following addresses, and I look forward to hearing from you. And with that, I will finish my conversation.
Great, Alan. Thank you so much for that. And thank you to the audience for tuning in today. It was a great last presentation. And I believe that we will, Alan, give you the contact info of the audience and vice versa. But once again, thank you guys for tuning in and thanks for the great presentation.
Thanks a lot. Have a great day.
Yep, you as well. Bye, everyone.